Hello, everyone. This is Terry Shea at Kublr. Today, we're going to be talking with you about enabling digital technologies, or enabling digital transformation with container technologies. With me today is Oleg Chunikin, our CTO, and I'm the Chief Revenue Officer at Kublr. Kublr is a company based in Washington, D.C. with a Kubernetes platform that makes it easier for IT operations and DevOps people to deploy, run, and manage container technologies. But the primary reason for the conversation today is really just to talk about how container technologies and practices like DevOps and cloud-native solutions enable digital transformation and what's driving that. We want this to be interactive, so there's a place for you to ask questions. Please feel free to do that, and we're going to move forward here. Hey, Oleg, say hi to the audience.
Hello.
Thanks, Oleg. So we're starting off talking about the pace of business accelerating, and the study that is here from Innosight highlights the fact that over the last 30 years or so, the length of time that companies spend on the Standard & Poor's 500, the list of the 500 largest public firms, has really decreased and has gone from nearly 40 years in the late 1970s to being predicted to be about less than 15 years in the early 20s. It's just a tremendous upheaval in the change between companies dominating their industry and then losing those sorts of competitive advantages. And a lot of this is being caused by disruptions related to technology. If we look at technology-driven market disruptors, this is what really gets a lot of the focus around conversations for digital transformation. So we all know, things about Uber and Lyft, how they've disrupted the taxi market, and they're really, technology-driven companies. The last time I went to a Blockbuster video store was quite a while ago. I mean, everybody uses streaming video, and Netflix has certainly been probably the dominant company in terms of video streaming. Airbnb has changed the hotel industry. Zipcar has changed the rental industry. And lesser-known organizations like Monzo, which is a UK bank, which built their front-end solution and their back-end banking apps on Kubernetes, have really been disrupting the financial services industry. Monzo, in 3 years, went from 0 to 750,000 customers with very little investment and a small team. So these sort of technologies are disrupting traditional markets and creating new business models that are growing very, 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 very quickly. But when we look at digital transformation on the whole, I was looking for a definition that was really more comprehensive. So I originally read about this in an MIT Sloan School of Management report, and the authors are listed, down bottom, George Westerman and Didier Bonnet and Lisa McAfee. But they focus on 3 different areas: transforming customer experience, so the customer-facing part of digital transformation, which again I think is what many people think of when they think of digital transformation. And that comes through things like customer understanding, which can include new applications like customer experience management applications, but also a lot of analytics that are required for looking at how your customers are interacting with you digitally. Top-line growth can be driven through, obviously, mobile and web apps, better e-commerce, better experience as well, and then customer touch points, because in managing customer experience, it's not only about transactional stuff. It's about developing a relationship and being available and providing value to your customers. But the other 2 areas listed here in terms of transforming operational processes and process digitalization, worker enablement, and performance management based on data are really equally important. And finally, they talk about transforming business models. So the second of the 3 items listed here, new digital businesses, is really what most of the first slide was about. So Uber, Lyft, Monzo, those sort of organizations really are new digital businesses that are disrupting markets, but also digitally modified businesses, so adding value to your business through digital offerings, that might take health information and provide that back to your consumers in digital format, or enable them to be monitored through, wearable devices, going back to a healthcare service provider. There are tons of examples like this where people are extending the way they interact with their customers and digitally modifying their businesses. And the last point here is on digital globalization, that as you digitize your business, you can use global resources and you can apply the same model and practices across the globe. So all of this change is really driving the need for speed. So we put up this Top Gun slide here. I feel the need for speed. And organizations really are finding that they need to move more quickly. You listen to CEOs and other executives talk about their businesses. They're focused on being able to rapidly engage in digital transformation initiatives that drive top-line growth and make the business more efficient and open up new opportunities. But in reality, there are a couple of common elements of digital transformation we're seeing. Experimentation and speed go hand in hand. So the idea of failing fast and trying new things and being able to update your applications quickly is a core component of digital transformation. And this is largely where container technologies, Kubernetes, DevOps, cloud native, and all these elements come together is in driving speed. But they're also related to the realignment and partnering between IT and the business. And so if you look at DevOps, and there's a great report out called The State of DevOps. It was recently released for 2018. Talks a lot about how organizations are engaging in a journey of DevOps, outlines 5 different stages, talks about a model called CAMS, which is about culture, automation, measurement, and sharing, and highlights the fact that when you ask different people in organizations how far are they along with their DevOps practices, C-level management folks think that they're further along than the people actually doing the work. So there's a lot of work to do there, but the idea that business and technology are aligned and that many organizations are creating smaller groups that are responsible for digital products that include marketing and business people and IT people and dev and ops all in one group. We're seeing more and more of that in the market. The use of cloud technologies and cloud native solutions, which are not exactly the same thing, is a key part of digital transformation. And then also modern application architectures. So to cover the last point, I think we wanted to go through a bit of the history of application architectures and infrastructure and application development processes over time. And Oleg, I'll pause here. This was something that we put together when our marketing director and you and I sat down a few weeks ago, and you sort of outlined this for us. Do you want to walk us through this slide here?
Yeah, sure. So I think many of us know, and some of us even witnessed this evolution of trends throughout history of IT, and it not only involves software architecture, but also how we manage and architect infrastructure and development and delivery processes, and in general processes in IT related areas. So where software architecture evolved from monolithic applications through multi-tier application, component applications, and architectures, service-oriented architectures were on the rise at some point. We were generally replaced or augmented with APIs, and now microservices are all the rage. In infrastructure, similar and aligned evolution happened from fixed, centralized hardware infrastructure. We all know that mainframes are still in service in some places, through web, mobile, data center-based applications, and to public and private clouds, software as a service, platforms as a service, infrastructure as a service. So today, infrastructure management becomes really flexible, distributed, and enables a lot of approaches that were not possible past. And process development while maybe not as noticeable, but also went through deep evolution from waterfall, agile practices to DevOps and service reliability, site reliability engineering now. And this all converges today in a number of trends, one of which is cloud native.
Well, thank you, Oleg. Yeah, I mean, I think this is a great representation that you put together of the fact that, you know, the software architecture, the infrastructure, and the development processes are really becoming linked together. And, you know, people hear things about infrastructure as code. We can talk about that a little bit later on when we do a sort of a pipeline chart talking about containers and how they enable, you know, faster delivery and deployment of applications. So moving from this to cloud native, what was at the bottom of your slide there, we wanted to define cloud native and talk about it for a minute here. So the original Cloud Native Computing Foundation definition, and Cloud Native Computing Foundation is the group that manages Kubernetes and the other open source projects listed here. It's also you know, underneath the auspices of the Linux Foundation. But they talked originally about how applications that were cloud native were containerized, and so we put Docker's image up there because Docker certainly popularized the use of container technologies. But they were dynamically orchestrated, and you know, maybe 18 months ago or even a year ago, we might have had more than one project listed there. But Kubernetes has certainly become the orchestration engine for containerized applications that everybody's supporting nowadays, right? And then, you know, also the third characteristic they said was that these applications were microservices oriented. So we put two of the open source projects around microservices, service meshes, one called Linkerd and the other Istio here as well. But underneath the Cloud Native Computing Foundation and then additional projects are listed because we wanted to highlight the fact that if you're not intimately involved in this area, you're probably not quite familiar with the fact that there are things like Prometheus for collecting metrics from systems running containers in Kubernetes, FluentD for logging, that if you're running a lot of microservices, you really do need to be able to trace back through those microservices, which have a lot of you know, peer-to-peer communication to see where bottlenecks are and to see what's breaking down, and that includes open tracing solutions. Helm as the package manager for these sorts of applications. Rook and Ceph are frequently talked about in terms of storage, and then the container network interface, CNI. There are a number of different overlay networks that can be put into Kubernetes clusters. There are a bunch of other projects we could have listed here as well, but if you're just getting into the space, it's important to understand that some of the things that you're using currently for maybe virtualized applications running on VMs are going to be augmented or replaced by projects that are more closely tied to Docker and containers and Kubernetes. So that's the cloud native applications. We also talk a little bit about how container technologies and other application and operational areas have created a perfect storm together. And this is a quote from Gartner that we've been using for a little while because it really highlights the idea that the application development, the architecture, the infrastructure management, and then the cloud capabilities, both public, private, and hybrid cloud, are part of a perfect storm of complementary solutions that are enabling cloud-native technologies to have a big impact on the way applications are developed, deployed, and managed. And so in the application development area, again, DevOps and moving to CI/CD is a big part of that. In the application architecture area, microservices and infrastructure management, infrastructure as code, is a big part of this as well. And that does change the relationship, I think, between development and operations. And that is part of the DevOps model as well, because as you're defining infrastructure as code, obviously things are shifting left to the developers, and operations needs to be involved in these decisions and these processes as well. And then the cloud, I don't think we need to tell people that the cloud is having a big impact upon organizations. It's pretty much there. So look, I might ask you to comment on some of these things here as well, but this is how cloud native and Kubernetes are enabling digital transformation. So in terms of faster application development and delivery, you're still writing applications. So, maybe your code time isn't quite as quick, but to have reusable components and to have a standardized deployment and release pipeline helps on the delivery side as well. So you don't really need to have as many language independent pipelines in your organization. So standardizing your development and deployment pipeline really does speed up application deployment delivery, and it's a requirement if you really want to get to continuous integration and continuous delivery. Fewer infrastructure configuration errors. So with containers, you're taking your application code and your dependencies and you're bundling them together into images. And so what you dev on and the stuff you run in QA and what you're deploying to production are all the same thing. So you don't wind up with those old problems of, hey, it worked in QA, but somebody changed a dot version of some app server in production and now it broke. So that just doesn't happen anymore. And that enables automation as well. Microservices we discussed here a bit. And I was going to ask you, Oleg, on the other side we were talking about Istio and Linkerd. On the microservices side, do you think that people will use the service mesh always with microservices, or is that something that you may not use all the time?
Well, in a sense, microservices are, if not synonymous, but very tightly related to service mesh, because microservices would not work without ability to route, reroute, dynamically reconnect, and switch those microservices, and this is exactly what service mesh is about. But also it's about not only about manageability of your microservices configuration, but also about transparency. So you are able with service mesh technologies, you are able to very tightly monitor, trace how calls are going through your system, how messages are going through your systems, and that's also very important because microservices architectures tend to become more complex and sort of ad hoc, more
right.
Driven by like quick changes in business environment. So you really need this transparency to understand your system.
Sure. Well, thanks, Oleg. And in terms of the other items listed here, I don't have to read through them all, but auto-scaling is certainly something that exists in the cloud, support for multiple environments, and the fact that Kubernetes provides self-healing applications through desired state management is just really great, right? So, when you have automation and your applications can scale, and if a pod is lost, it's automatically restarted. These sorts of things really provide a level of high availability and resiliency that is new. And then in terms of also being able to dynamically schedule applications and appropriate infrastructure, we'll talk a little bit about that in an upcoming slide, but there's a lot of scheduling capabilities in Kubernetes, so you can define where things run, what kind of resources they need. Do they need attachment to storage? Do they need persistent volumes? Can they run alongside other applications, or should they be separated? And Oleg's actually done separate webinars on advanced scheduling techniques with Kubernetes, which you can dive pretty deep into as well. So if anybody's interested in that, please reach out to us. But Oleg, I was going to let you lead here. This is a slide that we put together when we were talking the other week about the process of going from writing code to deploying applications into Kubernetes environment, right, on public, private, or hybrid clouds. So do you want to walk us through this?
Yeah, sure. So essentially what we tried to do here is to show how delivery and release pipeline may change with Kubernetes and container management, because while general structure stays the same, we go through code, binary artifacts, and deployment and release process, but Kubernetes and containers provide some changes in the process, some specifics. And actually one more item that we could put on the previous slide is quality assurance. Pretty much every consideration that Terry went through there is applicable in this area, so quality assurance is also benefits significantly from capabilities containers provide. But going specifically to this slide, we all know that software starts with the source code, and classic part of your code, source code, is usually build procedures, let's call them build scripts here, that normally automate your build and often delivery processes. Some new artifacts that come into the picture with containers and container orchestrations are shown here, Docker files and Helm charts. So Docker files represent essentially formal description of your container, so which binary components go into this or that Docker container image. And Helm chart, well, it doesn't have to be Helm chart, but Helm is just one of the most popular nowadays tools to manage packages on Kubernetes. An alternative may be KSON.NET, some other tool available from the community. We'll just call it Helm chart for the purpose of this slide. So your source code comes from source repository. GitHub, GitLab is most well known in this area. You use your normal build process to convert them into binary artifacts, and usually you store them in some binary repository unless they are ephemeral parts of your build process. And as build repositories, again, some of them more well-known products here are Nexus, Sonatype Nexus, or Artifactory, but there are others as well. And at this point, where containers come into play. So now you need to package those binary artifacts into a Docker container image to make sure that it can be distributed and run in different environments. So for that, you add a new integration pipeline step that uses Docker file and which specifies which binary artifact goes into that image, and you build a Docker image that again goes into your binary repository. In this case, it's going to be a Docker registry. After you have Docker image ready in your binary repo, you use Helm charts to deploy them as part of your application into a Kubernetes cluster in some of the environments. And again, Helm charts have sources that are stored in your source repository, and Helm charts may be packaged and stored in a Helm chart archive, which is again just another part of your binary repository. And as soon as you have both components, Docker images and Helm chart archives, you can either automatically or manually deploy your application into a Kubernetes cluster. And we need to keep in mind that you will most probably have more than one because you want to test it in a dev environment, or your developers will run it in a dev environment to verify that everything works or debug, etc. And dev environment may be a local Kubernetes cluster that you started with a Minikube, or it may be a special dev cluster, special purpose dev cluster in your cloud, or it may be even an ephemeral dev cluster in your cloud started by this development group just for this development stage or for this sprint or just for today. But after it's gone through development and gone through integration testing, went through integration testing, it's passed to QA, and QA team will probably instantiate the same application in a different cluster, which we called here a QA cluster. And after passing through QA process, it will go into production cluster eventually. What's most important in this process is that starting from dev, it's going to be the same binary artifact, the same Docker images, the same Helm chart archives that go through QA and then go to production cluster. So actually, many of the components of this process are based on the ideas manifested in 12-factor app manifesto that is a must for any DevOps team for today, at least a must to know. But in addition to those clusters where we run our applications, there may be more actually, because while this development or this release process may be backed by cloud software like GitHub Cloud or Cloud CI/CD software, and even binary repositories maybe in the cloud like Docker Hub, etc. For many organizations, it may be too early, or for different policy reasons, it may not be acceptable. So some or all of components of the tooling for that needs to be hosted by the organization itself. And Kubernetes actually provides a great way of doing that as a container orchestration and essentially infrastructure abstraction layer. So your local GitLab or Jenkins server or Nexus or all of them can run in a separate Kubernetes cluster, which is marked here as build cluster. So you see that very quickly you have a number of clusters on your hands. So this is where we see a place for another set of tools that is intended to manage and operate, to help operations multiple Kubernetes clusters across environments and clouds. And
yeah, well, thanks, Oleg. And so, you know, here in terms of that tooling, we're talking about Kublr being able to help simplify setting up these clusters that you're going to use to, you know, run your build processes and components, your binaries and CI/CD server and your source code management capabilities, and then also obviously for dev, QA, and production environments to run the containerized applications and services. So we could, you know, from here go into a deep dive on Kubernetes. Given our time limits today, we're not doing that. But we wanted to show sort of from production through, from development, from writing source code through deploying to production, a sample pipeline, and that also I think highlights how things are different from, you know, pipelines that don't involve containers. You know, the ability to include the dependencies, and then Helm charts as being one way to package applications and to include configuration as code. Oleg, in this sense, when you look at you know, people writing Helm charts, it's probably, you know, editing YAML files isn't something that everybody's good at, but also in some ways it pushes some of the IT operations functions left to the developer, right? I mean, the developer is now talking about what the IT operation or what the IT environment that these applications are going to run on needs to be. Is that right?
Yes and no. Because the most important part here is not that it essentially that some responsibilities change hands. They go from operations to developers. The most important is that this architecture provides much better delineation between responsibilities of different teams, and at the same time provides ability for much better organization of work together, essentially. So if operation team, so Kubernetes provides operations teams with good abstractions of resources, so operations can focus on infrastructure management, on I don't know, providing reliable cloud and private cloud services, and just define limits for development and DevOps teams using policies and governance features on top of Kubernetes, like this many resources you could use for your development, etc. And dev team takes much more control over how their application is deployed, and much more integration between application architecture and application deployment architecture. And at the same time, it all happens in controllable and reliable manner.
Yeah, so I take your point. It's not just a change in responsibilities; it's better delineation of responsibilities, and also though with I think the other slide we could put up here is there are, in a lot of situations you see sort of these circular sides, develop, test, deploy, and then learn, and then develop more, right? I mean, the point here relating to digital transformation is that as you standardize these pipelines, you can also update things more quickly, right? And as you put smaller pieces of code into containers, you can update at the container level instead of, having to rewrite your whole application every time you want to make changes. So,
yes.
Yeah. All right. Well, let's move forward here. Just a couple more slides, and we'll take any questions. I don't see any in the chat yet, and obviously you'll have our email as well. If you have questions afterwards, we can do that. This is a standard presentation slide we use when we're talking about Kublr. And so you can see digital transformation listed, or digital applications and transformation in parentheses listed on the left side of this, talking about applications and architectures, right? But we're also seeing a lot around data science and machine learning. And with Apache Spark 2.3, they've come out with native support for Kubernetes, so that data scientists can, stay in the tooling that they're used to, things like Jupyter, and still leverage Apache Spark on top of Kubernetes for reliable cluster management. And as we said early on, the idea that from a customer experience and operational management perspective, analytics and machine learning are becoming an increasingly important capability within enterprises that does relate to digital transformation as well. This is significant. We're also seeing a lot of the more popular and well-funded data science startups running their solutions on top of Kubernetes now. So this is a major shift. I mean, a few years ago, if you were talking about Apache for cluster management, you might have talked about Yarn or Marathon, but things there are moving to Kubernetes, as well as in terms of video streaming, Internet of Things, a lot of the software-defined networking and network function virtualization solutions, like the Open Network Automation Platform, which relies on some technology AT&T originally developed and is now open sourced and is part of the Linux Foundation. These things are all running on top of Kubernetes. So it's becoming a management layer and deployment layer and application runtime orchestration layer that can run these applications. And with Kublr, we wanted to be able to provide support for multiple environments. So large enterprises are still going to have hybrid applications. Everything is not moving to containers. You're going to have back-end systems that your front-end applications are communicating with. You're going to be taking and modernizing your applications and refactoring them. And so hybrid is an important consideration there. Certainly private cloud as well as multi-cloud requirements, so having the same solution in all these environments supporting all these applications. And edge computing is rapidly emerging. I mean, 5G is coming, and people are spending a lot of money on it. And with the increasing use cases around IoT, The edge is something that I think the architectures on are evolving currently as well. So how Kublr fits into this ecosystem? Kublr is a Kubernetes management platform that makes it easy for IT operations teams to deploy, run, and manage Kubernetes clusters that you can run your containerized applications in. It can deploy these across multiple cloud environments, and you can see AWS and Microsoft Azure and Google Cloud listed here, as well as bare metal and on top of VMs on-premise. On the left, you can see a cluster and the status information you get from that cluster. There's a whole bunch of drill-down capabilities there so that operations has visibility into the performance of the cluster. Kublr automatically deploys a number of security features, integrates with identity and access management solutions that enterprises have, provides the ability through RBAC to allow different groups to have different controls over their clusters that they run their applications in. So not only dev, QA, and prod, but different teams using Kubernetes for running different applications in different environments. And then in terms of building in logging, monitoring, and alerting capabilities, Kublr does a supreme job of that, and it provides both individual cluster level logging, monitoring, and alerting capabilities, but also a centralized capability. So you can see all your resources in all your environments, and you can have efficient utilization of those type of capabilities as well. Oleg, I think we're coming to the end here. I don't know if you have any final thoughts or words here as we conclude the presentation today.
No, I think you covered all the features very well, and don't think I would add anything at this point.
Well, so I don't see any questions currently in the QA chat. Again, we'll be available if people want to email us anything, and you could email Oleg at Kublr.com or Terry at Kublr.com, and we will be sending out this presentation and information to you as well. Oleg, I know you were up at a DevOps Days conference recently. Why don't you tell the audience what you were sharing with me earlier about where people are at in general with cloud-native technologies and Kubernetes. What did you find at the conference?
Well, I think the most interesting impression that I had from there is that many people are still in the learning stage. So they know about containers, they want to go in that direction, and some of them even started prototyping and building it, but they still are not ready to go full speed ahead, mainly because they don't yet understand how this whole infrastructure is going to be supported, how this infrastructure is going to be provided, and how responsibilities will shift when this process happens. So,
yeah, I think we're seeing that, on my side, in the sales side of the business as well, and in marketing, and when we're interacting with prospects and customers, that they're at a level. And there's obviously organizations that are very advanced and doing a lot. There are many enterprises that are just getting started here, and understanding the different roles and the different components of the solution so that they have confidence that they can actually move something to production, I think requires some hand-holding at the beginning. And so we're finding that, we're doing some of that work alongside providing Kublr to basically guide people as they develop capabilities here, right? So I see some of this as process DevOps, culture-oriented stuff, but a lot of it as just hand-holding as people begin to understand what it is they need to do, probably more outside the dev environment, right, in DevOps and Ops. I think developers can throw stuff into containers pretty easily, right?
Yes.
So, well, hey, that does it for today. We will send out this presentation to everybody who attended, as well as to people that registered and didn't show up. And look for the next online meetup or webinar coming soon from Kublr. Thank you.
Thank you for listening for us.